Okay, so we're taking notes for 3 and 4, and we're talking about transformations and congruence. It says, using rotations, what do you notice about the picture? Basically, this is A and this is A prime. If we rotate it 180 degrees, that's how we get there. So rotation about O, 180 degrees is A, you land on A prime. When two lines intersect, 4 angles are formed. Follow the steps below and label. Note that AE is not equal to EC and BE is not equal to ED. And then complete the following. So if we do a rotation of E and it's point C and we want to make C prime, well, we know it's not going to land on A because those aren't the same distances. So we would rotate it 180 degrees and we would land right here for C prime. Then if we do the same thing with B, B prime will be here. And then it asks us angle B prime E C prime is the same as, so B prime E and C prime is this angle, is the same as AED. And then the measure of BEC is the same as AED. Because these two angles are vertical angles, their measures is the same. So these are called vertical angles. And we have proven that they are congruent. So basically we just did our own little first proof together, proving that these two angles are congruent. And then we're going to solve for x here. It says it wants us to find FEG. We know that these are equal to each other because they are congruent. So we would do 5x minus 4 equals 3x plus 16. Move your 3x on both sides. 2x minus 4 equals 16. Add the 4 to both sides. 2x equals 20. Divide by 2. X equals 10, then plug it back in here. So 5 times 10 minus 4 is 46 degrees. So that's all for that first page. And then we're gonna go to the next one. So it says angles formed by transversals, worksheet 3-4. It says transversal is a line that intersects. Using the diagram on the right, which line is the transversal? The transversal is line M. What do you think is true about angle 5 and 6? And why? So we know 5 and 6. If we're thinking about it as a translation, we could say translate angle 5 along the vector RQ, which is basically our line M, maps angle 5 onto angle 6. They are corresponding angles, so we should have known that from our notes on worksheet 1. They're corresponding, and we just proved that they are also congruent by translating. So all it did was translate 5 to 6. They are the same measure. They're congruent. And then let's look at angle 3 and 2. Well, this is a little different because 3 is here and 2 is here. So we can translate angle 3 along vector RQ, then rotate 180 degrees. And then that maps, angle 3 maps onto angle 2. So guess what? Alternate interior are also congruent. And then we're going to look at 4 and 7. So 4 and 7, you would translate that along. So let's say translate angle 4 along vector RQ. Then rotate 180 degrees and maps angle 4 onto angle 7. These are called alternate exterior, and guess what? They are congruent. Last one. We have 1. Oh, you guys can't see when I'm pointing there. You have 1 and 2. So this time, these are same side interior. They don't look like the same measure. So let's see what we can prove about them. Angle 1 and angle 2. So if we translate angle 1 along vector RQ, and I should be putting these vector signs each time. Angle 1 maps onto angle 8. What we know about angle 8 and angle 2 and angle 8 are a linear pair. So that means that angle 1 and angle 2, this means like therefore. When we prove things, we use that. The 3 little dots mean therefore. Angle 1 and angle 2 are supplementary. So they're not a linear pair because they're not right next to each other making a line, but they are supplementary. So same side interior are supplementary. And just a little tip, we remember that means they add up to 180 degrees. And then I don't know if we have one more on worksheet 4. Yep. So one more on worksheet 4. We're just saying the type of relationship. 7 and 2, alternate interior. 2 and 6 are a linear pair. 2 and 5 are vertical. 5 and 4, alternate exterior. 2 and 3, same side interior. And 1 and 3 are corresponding. Use the diagram to help find the measure. Okay, let's figure some stuff out first up. If this is 50, we know that this is 50. This is 130. This is 130. If that was 50, this is 50. This is 130. This is 130. This is 50. If that was 50, this is 50. And this is 50. And that means this one's 130. And this is 130. And then, so we just fill them in. So angle 2 was 130. Angle 6 is 50. I'm putting a degree sign. Sorry, that looks like 500. Measure of angle 1 is 50. Angle 5 is 50. 4 is 130. 50. 130. And 130. Use the properties to find the following degrees. So this is 125. These two are corresponding. This is also 125. I know these two angles add up to 180. So 125 plus x plus 15 equals 180. I'll combine 125 and 15. And I get 140 plus x equals 180. Subtract 140 from both sides. X equals 40. Next one. I know angle 1 and angle 72 are the same because they're vertical. And then I know that these two add up to 180 because they're same side interior. So I can say x minus 8 plus 72 equals 180. I can combine these two, and I have x plus 64 equals 180. Subtract 64 from both sides. X equals 116. Last one, they are same side interior again. They add up to 180. 7x minus 8 plus 62 equals 180. I can combine these. I have 7x plus 54 equals 180. Minus 54 from both sides. 7x equals 126. Divide by 7, divide by 7. X equals 18. Okay, that is all that I have for you guys. Have a great day.